Hey, this is David D. Hilster. Oh my goodness, my throat right away when I just yell out for gets in my cut. Well, I want to welcome everybody to my Friday night live broadcast where I interact with people. Last week, boy, I messed up with my audio, but this week, no. But I'll tell you, it's a pretty exciting week. We found another, looks like critical thinker, Sabine Hossenfelder. I think there's her name. Let me look that up here. But she is the author of the book Lost in Math. And I did talk about that in my last video, so you want to take a look at that. Oh, there we go. And it's live. It's a little delayed, though, but I always check. And I want to welcome everybody who's already here and those people tuning in, because I know people do tune in because, you know, we have a pretty good audience. It keeps growing. And I want to thank all the new subscribers who have come by and subscribed to my channel. That's really great. I see that, you know, it's picking up, and a lot of times I'm trying to do some things on topic. The latest, of course, is that big New York Times article from Sabine, who's talking about the idea. And if you haven't seen that, go to the last video just yesterday. It's already got a lot of views for my channel, my modest channel. And she's talking about how she left particle physics. And that is quite shocking. She left, and not only did she leave, she's writing books and writing about that experience. And basically, not saying that, she's saying that in her opinion, smashing protons together at light speed and bigger energies is a way to try to find some things out about the universe. But the way they are doing it, the math that they're using, and this whole idea that is driven on aesthetics, so it's symmetry and it's beautiful. The universe has to, yeah, that's the part that she's obviously going after. And I did get the book. In fact, the book I have in an ebook form, and I already read probably through the first 40 or 50 pages, and it is quite good. Very interesting thesis, and I hope she may actually think about doing an interview, as I did with Dr. Alexander Unzicker. So let's hope for that. It'd be great, even better, because she has her own blog. And let me put that up there, see if I can find this thing. Sabine. There we go. We'll take a look at it. Here we come. It takes a little while. I will show it once I get there. Not the blog. We're going to go back to her homepage. Take a look at her. And here we go. Let's take a look. There she is, Sabine Hossenfelder. And you can see she's her research focuses on the foundation of physics, but her interest extends to the philosophy and sociology of science. Sabine partly works as a freelance science writer. Her writing's been published in Scientific American, New Scientist. Oh, wait a minute, I'm going to go back. I can do that. New Scientist, Quantum Magazine, Nautilus, and Aeon. It's like Aeon. She also uses animated videos and infographics to communicate her research. Oh, that's interesting. I've not seen them before. Oh, that looks like the Fractal lady. She'd love that shirt. Fractal Woman, Lori Gardy. So what did the last one say there? She is an experienced public speaker. Well, that's really great. So, wow. Maybe I can get her to do at least a video conference with us at our conference in, wow, it's this year already, in June. And we're going to be at the University of Washington. Let me see if I can get to that place here. Let me browse around to it. 2019.naturalphilosophy.org. That should get us to the place. And I believe I have a video. I think I've already shown it. I've got a little infographic, that's what they call them, for the conference, but I'm waiting for that to come up. So hello everybody. Have any questions? Say hello. Great to see you. But oh yeah, here we go. Let me show you. I've been talking a lot of times without showing people, but there's the promo video, and here's the poster for the event. Critical Thinkers Conference, Becoming Science Woke. Of course, that's going to be, we're going to have our our launch of our website before then. Maybe we'll even coincide it at that time, but I think it'd be better to get it out before then. And of course, we have this is a view of the campus where we'll be at the University of Washington, and that happens to be the place where Dr. Gerald Pollack is a professor, and he has discovered what he calls a fourth state of water. And he's also going to talk about science activism, and he's going to also receive our Lifetime Achievement Award. He's spoken numerous times at our conference at CMPS. I think he spoke, I don't know if it was in Albuquerque, but I think he spoke at the University of Maryland as well, and we hosted it there. So, do you know if Donna Eberly was present at the conference? Will be present. Oh, I'm not sure. I think Donna Eberly, for those of you who don't know, was actually the president of this organization, or its predecessor of this organization, for some time. And actually, I put a YouTube of her, but let me go to the database, db.naturalphilosophy.org. Let's go there, and there we go. This is our database where you can look everything up. You can go to the find. It's not working super perfect all the time, but you can see we have 2,900 scientists. If you want to put in her name, Spencer, you can search for it, and you will get, there we go, Dr. Domina Eberly Spencer. She has a PhD in mathematics from MIT. People always accuse us of not having people with credentials. Well, she certainly did, and does. And she is 98, folks. So I haven't heard about anything if she's still alive. I know she is a vegetarian, like myself. I'm actually a little bit more than that. I'm a whole plant-based diet. I reversed my heart disease. Yes. So she actually talked about diet numerous times. But she has 77 abstracts. She was at 21 events, and this is what's great about our, we haven't been keeping it up as much, but she was at the very first Natural Philosophy Alliance 2 decades and 4 years ago. In fact, you want to see who's at that? You can go and click on that and find out who was there. There were 58 abstracts, 28 participants, and those people. Jeff Barr was there? You know, I don't think this is right. You can see it's all screwed up here. So yeah, it was in 1994, but that is not correct at all. So I'm going to have to find out what those links are. I told you, it's one of the things I need to do. If we had an organization that had a lot of money, we'd be fixing all these things because we've got a great database. But yeah, she's 98. We did happen to put a video of her. So that's a YouTube. Let me see here. I'd like to go offline before I go start bopping around here. It's nothing worse than watching people flounder around on the internet. So I'm going to go to YouTube, and if you go to, let's see, youtube.naturalphilosophy.org, I think that will take you directly to our page. Yes, it does. Hey, we keep going. You know, ever since I started this channel, almost 2 years ago, John Chappelle didn't have a whole lot of subscribers, and now we're up to 340, and we keep growing. But there it is. This is Dr. Eberly Spencer would talk in 1994, probably at that conference that I was trying to get to. You can see the old VHS tapes that we've converted, and there. I don't have the June 22nd, 1994. That was 2 years before I got to know them, and this is a talk. I think this looks like, yes it is. Oh my gosh, that's John Chappelle. There he is. That's John Chappelle right there. You know, we don't worship these guys, but he is the founder of this organization, and that's Domina Spencer. We do have videos of John Chappelle as well, and you can see that's the name we have under him. We made this, and that's our logo, the phi sign. the symbol phi in Greek alphabet, which happens to be philosophy, and actually the word for natural as well. So as you can see, she's talking about the velocity of light, 1905. Posture of the velocity of light is in free space is always a constant c. And then in Ritz, he said the velocity of light is a constant c with respect to its emitter. So she's, I think, in this talk going to talk about, because she did not believe in the constancy of the speed of light. And for those who don't, that also don't know, hey Lisa, how you doing? Yeah, haircut, Lisa. You know, I got a party this weekend because my wife's Brazilian and we got a big Brazilian party, so I got to look presentable, and I just let my hair go. But anyways, this is I'm showing a little bit because somebody asked about Dr. Eberle Spencer. This is in the math. If you watch my movie, EinsteinWrong.com, if you're interested in seeing it and you haven't seen it, and you are subscribed to me right now, and you're listening in and you want to see it, I will send you a free viewing of it. But some of it was filmed in this room because this was the mathematics room at the University of Connecticut, where she was a professor, and then they let us use this. She was a sprite young 76 here. So, but she published back with her husband, Moon and Spencer. It was can't remember his first name, but it's Moon, and she said there were two postulates of special relativity, and both were wrong. She says that in my film. If you watch that in my film, you'll see that. So hopefully you'll take a look at that. If you haven't, McCauslin video as well. Yeah, I recommend his A Scientific Adventure book. I probably knew about that or know about it, but I have not. It's not ringing a bell right now. But anyways, I do want to. I'm going to watch this going on and on. I didn't want to put any. But you can watch that. That's at the John Chappell. Actually, I'm trying to move over some of these from the MPA because, believe it or not, the Natural Philosophy Alliance, we handed it over to the, we pretty much almost left the organization, Greg Folk and I, and handed it over to the directors, other directors, and handed everything over to them. And that was one of the stupid things I've ever done in my life, I will tell you. But the good thing about it is we started over with a better, more organized, and we lost money, of course, and we lost control of some things, including the NPA's YouTube channel. But I can download those, and I'm starting to download them and move them over. You can see I've done some of them that we have a lot of hits on. So I am trying to move those over. There's some there that's not, it's not like a huge loss. The stuff that we're doing today is much more interesting. A lot of it, but a lot of it, the stuff in the past is very good too. And I actually have some videos I need to convert, and I can convert VHS videos. So, but today's topic, what I was planning to talk about, and will talk about, and put that down, is something I came up with this week. And you know me, I'm not afraid to come up with these, constantly come up with better ideas as much as I can to try to get the word out about all this. I think we're making inroads, like I said earlier. If you just joined, if you haven't seen my latest video, take a look at it. It is absolutely shocking that the New York Times would in fact publish something from this wonderful lady, Sabine Hossenfelder, who got her PhD in physics from a particle accelerator, trying to make predictions. But she wrote the book, I think it's here, let me see, Research Writing Book. And this is the book she read, and I just bought it, and I've read through part of it already. I would probably recommend anybody who's interested. It doesn't have any math in it. Very little math, and so it's a really great book, and she talks about basically how beauty leads physics astray. But that's really great. But what I do want to talk about today, and that is, let me see here, I call it Critical Thinkers Marketplace. Now, I didn't prepare anything for this, and and prepare in the sense of, you know, visuals or graphics or I just wanted to sort of bring this whole concept to you. And I was trying to think of it about what's going on. Let's go to the website, which is basically going to be Science Woke. If you haven't, of course, haven't seen it, it's because why? This is what you'll see. I'll go to the dashboard here, and this is what you'll see if you go to it. See, come on. Right here. Let's do a live preview. So if you go to sciencewoke.org, you will see this coming soon. You can subscribe to let yourself be known or find out when we will actually go live. And this will definitely go live before June. We have so much work to do on it, but we're making great inroads to it. So anyways, in this on this website, one of the really important articles, I have a bunch of articles that I've been writing, and I put them right up front with these graphics, of course, where it's become Science Woke. Model revolution is here, and here's why. And that's one I've showed numerous times, and that's where we are. We are in model revolution. This is something that is all my work. This is not necessarily, you know, corroborated by many people, but it's corroborated because I'm really pretty much putting down what is happening, and that is the models that we continue to look at, physical models for light and gravity, were started in the 1600s. They weren't started in the 1900s or the 2000s, and we are still in that. The model drift did start happening because once Newton talked and gave us an equation for gravity and was talking about light and working with light, people said, what is light? Oh, it's the luminous ether, or gravity is for gravitons, or the mundane, ultra-mundane corpuscle. The reason they say that is the corpuscle was their sort of word for the particles at that time, small, really small things, and ultra-mundane meant it didn't interact with anything, because gravity sort of, you know, otherwise it would do things like expand the Earth, but it does do that. And then, of course, model crisis is when Einstein came along and says, folks, I am going to give you the laws of the universe. We're going to show that these laws are there, and that is the speed of light is constant for all observers, and that physics has to be the same in all inertial frames, moving frames. And of course, you get into the craziness of special relativity where mass increases, all that kind of stuff. But anyways, the reason I'm showing this, and this has to do with Critical Thinkers Marketplace, is because right here, you're going to see model revolution. And what does that mean in the model revolution? It means there's going to, according to Kuhn, Mr. Kuhn there, who wrote the science, was considered one of the great books, Paradigm Shift. I think he came up with Paradigm Shift, I think. Don't quote me, but I've heard that before. And he wrote on the structure of scientific revolution. And he says you get to a point where things break down, and we have many models trying to describe the same thing. Of course, we've had that in standard model, but according to Hussenfelder, she says in this book that they all have been proven wrong. Does that mean that when we're looking at the ones, the models, and I'll go to our website, and that's what's going to be so great about this website. This is all shrunk down. Let me come and squeeze my head over here. There we go. And you come over here and you click on New Theories. And then we got these people and their new theories. Well, when you look at all these different theories, we have the energy wave theory, the infinite universe theory, we have the universal cycle theory, we have autodynamics, we have the particle model with these two crackpots there, we have fractals and black holes, we have the universal force equations, which are quite amazing, Yonel-Deneuve from the Deneuve effect, rudimentary ether, we have prime matter particles from Neil Adams. We have the living universe theory from Carter. We have space lattice theory, and that's with Bruce Nappy. All of these things. What are we supposed to do? What are we supposed to do? Well, the whole idea is, well, we have a critical thinkers marketplace. What does that mean? It means when you come to our conference, we've got a lot of contenders, and there's no winner yet. Now, the difference between us and those funky theories with multiverses and the things that you will read in Sabine's book, Lost in Math, this one here, the difference is that the people who are writing the theories for in the mainstream science and particle physics, those people are off so far away from physicality. They are in their own systems. They are lost in math. That's why you see this title here. That's why this person, Sabine, she left particle physics because she couldn't take it anymore. And if you read if you go and watch my video, please do the one right before this. So if you're watching this in recording, go back one video, and you will see that in fact, she says she got out of it because people were all into the beauty of it and all to the math, and there was nothing coming out. Everything that at the energy levels at that big collider, the Large Hadron Collider, at those energy levels, none of the predictions came out. And she even says was it? I think it was in that article. She said that one of the blips on the radar during their experimentation, now that the Large Hadron Collider shut down, but when they were still running it, working with it, they said, "Oh, we think we got a new particle." They had 500 papers and 500 theories about what that new particle would be, and guess what? It turned out to be noise. So, what we have are people who are lost in math, and something's wrong. But if you go to see, look at that, my programming. This is a ordering problem, the database, that there's one person here that doesn't have an order, so we get a blank. What am I doing? Explaining the programming, PHP programming I do to make this site work. It is a theme that I actually, we bought, but I've been modifying it. And one of the things about it is, one of the things about our organization, as these didn't come in by saying, "Oh, we got a new blip on the radar, let's do it." These theories, all of them, are reconstructing from almost scratch. The only things that they do acknowledge, most of them, is yes, there's a nucleus and there's stuff that goes around it, but after that we don't know. And in fact, if you look and talk with, let's see if I can go to the scientists. Hello, click on this. Yeah, the scientists. Let me click on that. I think we have Alexander Unziker there. Do we? There he is, Alexander Unziker. We have Alexander. Sorry, I had a phone call right there. Alexander Unziker talks about having the throwing out all of physics since 1930, and that, my friends, is a very, very bold statement. So, yeah, we absolutely, if that's the case, if we're going to throw out physics for just a second here, I'm going to do it online. Please talk later. Okay, sorry about that. So what I'm saying is that if we're going to throw out physics since 1930, you're pretty much throwing out everything below the nucleus. You're throwing out quarks, you're throwing out the neutrino, you're throwing out W and Z particles, you're throwing out gluons, you're throwing out the Higgs boson, all those things. Now, although Sabine sounds like, when I read her stuff, she doesn't go that far, Alexander Unziker certainly does, which means when we go to this website, and go to the new theories, and then you click on a new theory. Let's go down here and click on these Yahoos, the particle model. You're going to come in here and you'll be able to read what, in a nutshell, what is, what are these theories? What are they there for? What are they trying to do? And so what does that mean? What it means is we have to understand all of you have to understand very clearly that, in fact, we are in model revolution. When we're in model revolution, that means we don't have a solution, one solution. We have many. If I were to tell you who are the front runners, ether and the particle model, in my opinions, are those ether models and our particle model are the ones that are probably more complete. A lot of other models have been started, but they haven't delved down and described things at the level, for instance, that we have. I'll give you a good example is Glenn Burkert, who is an etherist. He said that electricity was just light captured in inside the waves of ether inside of wires that sort of kept conformed and inside of wires, and but he never went in and explained, for instance, magnetic fields. He didn't explain the way that all this stuff would work with electronic components, for instance, which our particle model does. So we go further with that, but again, it's not accepted. It's not like everybody looks at Dave and De Hilster and De Hilster's particle model and says, "That's it, Dave. You guys got it. Let's go forward with it." Jeff Yee has a very complete model, although he hasn't answered some of those questions as well, but it's very complete. But these are our models that start from scratch. You have the other ones that I showed on that website. And you can see that this website is going to be really great, but I need time to do it. And it's my brain bust. I just can't turn up the creativity and write about every one of these in a creative way. So I'm trying to get people to help out. So hey everybody, Deltron, hello Dave, Deltron 31 and Steve Beck, light is a corpuscle. Yeah, but so what I'm saying to all of you is that one of the things that even the authors of these different candidates in the marketplace for critical thinkers, a lot of them will think, well, nope, I'm right, everybody else is wrong. Sort of like again, I'm not talking bad, but like a religion. Well, my religion's right, your religion's wrong. My language is better than your language. My theory is better than your theory. And we have to understand that right now, there's not one that is winning. If ether was really correct, it would have attracted everybody and they all be working on it. It attracts more people because they like light being a wave through medium, but that's not the only one. So you as people who are critical thinkers, who are science woke, maybe you're even working on your own stuff, you have to understand right now it's a marketplace of these things. So anyways, if you guys have any questions, let me know. And I know people are coming and going with this because we got up to 1,100 viewers. Now, one of the things people ask me, oh, you had a lot more subscribers. Well, what they did is they went through and they actually purged lots of subscribers because I guess a lot of them were not real. And I think they did that to a lot of channels. So right now, I guess the people that are there, they're being able to tell the difference between people who are real and sort of spam type of accounts. So anyways, that's one of the reasons. But we're, I think we went down to about 1,000 after that, and then it's slowly, not slowly, but it's pretty good, averaging 3 or 4 new people a day. And I welcome everybody who's come this way. And also for those of you who are new to the channel, the idea of this channel is pretty simple, is to show you that actually there are people who've been working outside of mainstream for decades and decades. That's what I'm always saying, but it's very true. And we have made progress. And so, in fact, one of the articles I'm writing is that we've made fantastic progress outside the mainstream. I think what people are looking for, and that's why I'm continue to talk about this is a critical thinkers marketplace, and that is right now we've got a lot of data. I'll give you an example of how we're not exactly sure still as to which theories are most promising. For instance, our theory, we're not going to recreate quarks. We don't believe quarks are real. We believe they were invented and that the way they found them was totally bogus. And same with the Higgs boson. So we will not recreate this. We don't recreate the neutrino because that was a way to save special relativity. But somebody like Jeff Yee, he accepts those. And so in his model, he comes up with a way to do that. Now, it's very nice. It's very symmetrical, modular. I know I'm going to send yawns through the universe here. But it's basically... with somebody like Jeff Yee, he will more closely, and I asked him a question. He gave a talk on our Saturday morning talks, the CMPS, every Saturday morning from East Coast time, which is 10 a.m. East Coast time, 7 a.m. West Coast time, America, and then of course later in the afternoon, I think 5 hours before that, so like 3 in the afternoon in Europe. That's why we do it at that time on Saturday. We have talks, and one of the people who gave a talk, if you haven't seen it, go to youtube.naturalphilosophy.org, and you're going to see our recordings of those sessions. They're 2 hours long. You can go in. It's a video conference, so you can have your video. You can video chat to other people. It holds up to 100 people. You know, so we usually have a couple dozen people there watching and interacting. And he talked about his model, Jeff Yee, the energy wave model. And what I did, I asked him a question. I says, Jeff, you know, I don't believe that the quark exists. Don't also believe that the neutrino exists. And why did you name those? And he says, well, we just use names that are common. So he's sort of, I think people are inspired in their models that there's this very small neutral type of particle, and so that they dub that the neutrino, because that's what the neutrino is. For those who don't know what the neutrino is supposedly, it was invented because it was postulated. They call it postulate. Postulate is a wonderful way to say invented. They invented it and tried to find it decades later. A particle that took away energy, that special relativity has magical energy. So Einstein says as you get close to the speed of light, you have more energy, because as you get close to the speed of light, mass increases. If mass increases, there's got to be more energy. And because of that, they say, okay, then we're only measuring exactly what we predicted, which is Newtonian, which is just chemistry, no magical relativity needed. Guess what? We measure exactly that. But you know, Pauli said, no, in 1930, you can't do that if you are going to use special relativity. And therefore, there's going to have to be more energy there. And if there's more energy there and we can't see it, then there must be a particle taking it away. And that's like the dark matter. The neutrino is the same thing. He wanted to call it the neutron, but somebody actually found what they called a neutron in the center of atoms, so he had to call it the neutrino. And then they couldn't find it forever. And of course, they said they found it, but of course, if you go to neutrino.autodynamics.org, you will see Carozani's rebuttal to what they found. In fact, it's really shaky as to what they are finding. And the neutrino detectors do detect something, and that is what? False hits. Because neutrino detectors are buried in mines. They're in Antarctica. They're way underground, in caves. Anybody know why? Can anybody tell me? Teacher, I know. The answer is to shield it from false hits. And a friend of mine, my best friend who is a programmer, he and I are programmers. I've been working for over 30 years, and he is a anti-neutrino guy to the max, and he's not even into it like I am. Oh, no. Sorry. You know what he says? The perfect neutrino shield will shield all the false hits, so there'll be no neutrinos detected. So anyways, it's something that some people say, you know, again, the neutrino is something I don't believe that exists, so we don't try to include it in our models. So again, what I'm talking about tonight is the critical thinkers marketplace. There's a lot of different ideas, a lot of different things out there, and you've got to read them. And you should read as many as you can. One of the things that a lot of people are asking me to talk about specifically is the electric universe. I have talked about that more of in a positive way, in the sense of that they are critical thinkers. They absolutely are. They're challenging mainstream. They absolutely are. And they have 100% right to do that and should do it. The way I look at science is if that is floating your boat and you think that the universe is all electrical, then go at it and prove it to the rest of the world. That's what we all should be doing, and that's what we're all doing with our models. If our model, my dad and I, it's more curiosity. We just sort of fell upon it, and then we just started using it, and it seems to be working. And we thought, okay, I mean, we're not so. My father and I are not hell bent in showing that our model is the best. Although it just answers all the questions I have, other models don't answer. So I guess that's the reason we keep working on it. But you know, it's the idea for all of you is that do not necessarily go after and say, oh, I'm sort of leaning toward it. This is not like fashion. It's not like, you know, I like horror movies. Oh, I like action adventure movies. You know, this is our scientists, and they're trying to give physicality to the world. And if I were to tell you one difference between mainstream science and their models, which are failing miserably, which of course the New York Times article that came out, and I talk about that in my last video, says, and that is, all these ideas that are mathematical have been proven wrong because none of them have come to fruition. They said when we got to the Large Hadron Collider, we're going to see all these things happen. Multi-universes are going to pop out. I don't know, multi-universes, multi-dimensions. We're going to find dark particle, all kinds of stuff. Whereas when we're talking about critical thinkers, people in our group who are doing, who have their models, their own models, most all of them, not all of them, but most all of them are trying to give physicality to things that we don't have physicality to. For instance, Dr. Bill Lucas, his world and his electrons are toroids, and he has some evidence that he points to for that fact. So, photon's a neutral particle. Why need a damn neutrino when we already have the photon? Hey Dave, got a question about the expanding Earth theory. What are some of the ideas of why the Earth is expanding? Okay, that you can actually read in this book. Here, I'll get you this book right here. I know I've tried to keep my books. You notice I got a lot more books back there. That's because I've gone to my other bookshelf and I have found books that are absolutely amazing that I forgot I have. Here's what I would recommend to you, Dalton. 31. This book just came out. Dr. James Maxlow, Beyond Plate Tectonics. And in chapter 11, he talks exactly about that. I believe it's chapter 11 or chapter 13. It's one of those. Hold on. Hold on, hold on. There we go. Yep, I was right. There we go. Ha! I'm doing terrible. Oh, it's over here, Dave. Hello. So it says, proposed causal mechanism. It may be fundamentally wrong to attempt to extrapolate the laws of physics as we know today to times of the order of the age of the Earth and of the universe. So basically, he goes through and he gives his thoughts about that, and his leaning to in that area, to give it sort of in a nutshell, is that in fact the mass is coming from the sun. We know the sun is shooting out. You know how we always say that astronauts can die from the radiation from the sun? Well, it's not light. That's one of the things they don't talk about. Well, it's these waves that penetrate. No, a lot of it has to do with protons. If you're the mass of most of the mass of the universe is the nucleus. We call them protons, but I call them the nucleons, because this idea of pro is because it's like positron and negative, you know, electron is negative, positive. Let's just call it a nucleus. The nucleus of the atom is what's heavy, and those are getting shot out from the sun as well. It blows apart atoms, and so when those atoms are blown apart, they can get caught into the magnetic field of the Earth, and they can enter in, he says, the poles. I say mostly entering in the South Pole. That's why we have more expansion. In the South, take a look at the Earth. Take a globe. Look at the Earth. Here is the globe. It's hard to see because it's got so much stuff in it, but there's the United States and South America. For those people, there's Africa. But if you turn it and you look at Antarctica, you're going to notice that it doesn't have, except for Antarctica, there's very little mass you see there. Whereas if you turn it around, you look on this side, you've got all kinds of mass. You've got Canada there, you've got all of Russia, and you have a lot more land than you do have, well, that's not true, but a lot more land on this side. Well, that's because maybe the circular motion of the particles that make up the magnetic field will suck in those protons, and he says in the D layer, that there's layers of inside the Earth, that they recombine and they get caught and they become atoms. They get reconstructed. So that's what he is saying, and that's what my father and I are saying. The same thing is that the atoms are blown apart, so you have whatever goes around the outside and whatever is the nucleus, and those things get recombined inside the Earth. And in all bodies, in fact, well, probably, you know, I won't say that, but I think most bodies, and that would be the reason. That would be one mechanism. Now, there's another mechanism, which is Dr. Bill Lucas. He calls the expanding Earth the growth of the Earth. He says that's from the decay of gravity. Now, I am not an expert on what that means, but for those who want to look at that, if you want to even enter in contact with him and email him, he will explain that to you, I'm sure, very well. Okay, yeah, thanks, Dave. I'll have to check it out. Okay. Sean Gru said Earth is expanding because of magnetic poles pulling mass. Yeah. Yeah. The difference is, of course, people don't say what the magnetic fields are. We have a lot of people talking about, that's why, like in our model, it's the same particle, actually. All you have are the same particle that goes around the nucleus is the same particle that makes gravity, that makes light, all that kind of stuff. It's the same thing that flows around and to make the magnetic fields. And, you know, those flows will eventually, you know, capture those particles and come in. But I don't even think that's the only way. I think that, you know, nucleuses are flying in all the time. I see people bopping in and bopping out, probably because they don't know what the channel is and they're not sure what I'm rambling on about. But I do appreciate it, and any questions that you have, you know, let me know. We're already 42 minutes into this. So, but again, I can't emphasize more to all of you. Think to yourself, this is like you're going shopping, basically. It is a marketplace, and people are trying to sell you their ideas. And that's the way you look at it. That's the way I try to look at it. And you can't blame a person, for instance, who I know almost for certain that the neutrino doesn't exist. And Karazani shows exactly why it was postulated and why you don't need it, and shows you when you take away Einstein's problem, here you don't even need it. That is, we have a simpler system, so without it, again, that's Occam's razor. But if you are a person like myself, I love Jeff Yee's model. I don't think neutrinos exist. He calls something a neutrino. I don't think quarks exist, but he has things called quarks. But his model is very good, in my opinion. And it's a simplification. I think it still misses a few things, but I am not going to say that his model could be the one that people will gravitate to and say, yeah, this is the way the universe is working. So, you know, that is very possible. So what I want you guys to do is always remember, please give everything a chance. Please take a look at things. Let people know. I mean, let yourself look at those. Give it a chance. Every time I get a new book on something that's a totally different way to look at the world and the universe, I read it, because I'm thinking, wow, a person has a totally different outlook on the way maybe the universe works. You know, like James Carter, he says that there's no gravity. What's happening is that we're being pushed. down, that the Earth is pushing us up. Here's the Earth, it's pushing us up. Well, how could it push us up? Well, because everything's expanding, and with that expansion, we have this idea, and we feel that it's gravity. You could be right. Maybe that's the way the universe works. We have to be cognizant of this. Don't marry. My dad and I, if you look at the website for our particle model, I'll show it to you. It says, in a nutshell, right here, healthy skepticism. This is what we're writing. It's a very short blurb. We're trying to write things that are short. This is for, once you click on ours, the new theory or model, particle model. That's ours. Well, I put here, I said, healthy skepticism. If you ask either Bob or Dave what they think about their own model, it's got a question mark. I mean, this is terrible English. You can tell it's not done. They would answer with a healthy dose of skepticism. They are constantly trying to break their own model. That's true. I mean, I'm constantly saying, am I finding a fatal flaw that this thing is just isn't going to work? Oh, and here are some articles we're going to be writing. No negatives in physical electronic circuits and physics itself. That's a whole nother story. There's no negatives. Up there's our particle model in a nutshell. Anyways, I'm not here to, well, I'm here. We would be selling our wares. We would be saying, hey, here's this model, and maybe be interesting to you to take a look at it, and maybe you'll find out, hey, that makes sense to me. And you can subscribe to the particle model, or you subscribe to Jeff Yee's energy wave theory, or you'll subscribe to Electric Universe, and that they're the way they describe things with Electric Universe, that the Grand Canyon was caused by a giant lightning bolt, scarring. So, wow, not many questions tonight. I must be really unstimulating in my talk tonight. Sometimes, it works out. Sometimes you've got those things going and your interaction with the audience, and sometimes it just I've learned with events. I've done a lot of events with the Samba groups, some pretty big ones, tens of thousands of people. And sometimes you do a party or an event or a happening, and it just doesn't get legs. It just doesn't have that energy. Maybe I don't have that energy tonight, but I will again. Let's see if I can pull out some books here. Here we go. The Marketplace, Autodynamics. This book. I'm not sure if you can get this anymore online. I think there may be a place. I'll have to check it out. I should work on that. But this is the fundamental, it says right here, fundamental basis for new relativistic mechanics. So it's not so much all-encompassing theory. Here we go, another one. By Dr. Bill Lucas, Charles W. Lucas, William, Charles Bill, he likes to be called Bill, and the universal force. Basically says, I have unified the forces. It's very mathematical. Has toroids. Does he have toroids in here? Yes, he does. There we go. There, you can see it right there. Oh, wrong. Sorry. I keep doing that. Very specific. And he talks about how the universe organizes itself. Bode's law. He also talks about redshift. He also talks about symmetry and chirality. What's chiral? Chiral is like the left hand. When you have a corkscrew, it goes in one direction or it goes in another. It actually has a direction. So a corkscrew, you can have two of them and they can be opposite of each other. It's called chirality. And this is a really interesting thing people have shown many times. And that is what? That's the solar system going through, moving along in the galaxies and stuff. And he talks about all of these things related to even the patterns that come up in odd numbers, etc., in nature itself, the chirality. And all of this has to do with his stuff at the subatomic level all the way to the... and here is a spherical and chiral symmetry of the neon 20 atom. Right there. Now you're saying, well, how could that be? Well, it could be very well what this is. And so here is a guy with, and not only that, expansion stretch marks. He talks about the mechanism for, here it is. Is there any evidence that the force of gravity has decayed? Yes, the expansion of the Earth and the resulting separation of the continents have been documented. He takes that as a fact. According to Hooke's law of elasticity in 3 dimensions, elastic material as the crust expands very slowly due to the change of the springs of gravity. So he's saying that. So there is another person in the marketplace saying, "I come to my booth. I have the answer to the question." Oh, I got my shirt on today. We founded the John Chappell University of Natural Philosophy. I came up with a great idea just today. What we need to do is we're going to be teaching, it's sort of an idea I had, but I really solidified it. We're going to put courses in there. You know what the course is going to be? We're going to teach you a course, and every person who has a theory is going to teach you a course. And you know what they're going to do? This is a nice idea I came up with. Tell me what you think about this idea, you guys. This is the idea. The idea is we are going to, and that was sort of what I was going to do with ours, but I really solidified it very simply. That we're going to give courses in each of everybody's models. And we're going to teach it as if that model was accepted by everybody. So we would teach you. Instead of us trying to justify it and saying, well, our model's better than the others, we're just going to teach them. Is that just brilliant? No, there's no such thing as genius. So that is not a genius. It's a good idea. It's a damn good idea, in my opinion. But, all right, let's see another one here. Here we go. Another one. I didn't plan this, but it's working out really well. The Universal Cycle Theory by Stephen Putz and Glenn Burkert. This is when I first learned about neomechanics, and I was blown away. I wasn't so much blown away by the actual the cycle theory, but the neomechanics in here was one of my great aha moments in history. What was that, Dave? Just words coming out randomly? No, this was my aha moment for myself when it came to neomechanics and the infinite levels of the universe and how all that worked. This blew me away. Great book. Definitely worth you reading. See if I have some other ones here. I do have, oh yeah, of course. This is James Carter, and he calls it the living universe theory. And every book he sends me has a different title. I think he has the same book, he just puts different titles to get people attracted. So he's marketing his book as well in the Critical Thinkers Marketplace, Big Bang Physics Without Metaphysical Assumptions. He also sent me another one that says more like Einstein's off his rocker. He's absolutely nuts. And, you know, that's what that was about. Henderson, Common Sense, A Return to Common Sense. Common Sense, The Demise of Relativity. This one's by Robert Henderson. I do know him. I'm not sure he's alive anymore. But cool, interesting book. And let's see, what else? I was going so well there. I have some more back here. Oh, there's my dad's stuff. Story of Physics. Blah, blah, blah. Well, that's the ones I have. I'm sure there are some other ones, but I'm just not grabbing those right now. They're not, but there was another one by Mr. Come on, where are you? Trying to find the other book from James Carter because he put a different title on it, and I love his titles. They're just so cool. So probably have it on my desk somewhere over there where I was reading it. Probably. Anyways, that's the marketplace that I've been wanting to talk about tonight. Gravity is particles. Yeah. How did the relativity pole turn out? Oh, well, I can show you that because, let's see here. Oh, I can, don't know how you see it on, I know how to see it. Well, oh, that one, it turned out like super in favor, both were wrong. I mean, almost everybody came up with both were wrong. So let me see here. Sorry about that, folks. I'm trying to get this back here, make sure I do this correctly, but I can report it to you easier actually than hold on. Come here. If you go to that, you go to the community. So if you're on a phone, you can go to the community and you can see it. So far there are 22 votes. 91% says special and general relativity are wrong, both of them, and 9% says neither. So that's probably 2 votes to 20, I guess. And that's pretty shocking, actually. I expected more, but I think the people who see it are the only people who see it are those people who are subscribed to the channel. I don't think necessarily people who see it who aren't. Fossology. I am learning special relativity now in my modern physics class. I don't understand length contraction. Why is the speed of light constant through any reference frame? Okay, if you are still there, it's 9:45. Yes, you are. Fossology. Well, I can tell you what they'll teach you and what they say. I'm learning special relativity with my modern friends. I don't understand length contraction. Well, it turns out that Einstein has 2 postulates. Postulates are things that or assumptions that you cannot prove or disprove. Assumptions or postulates are those things that you assume to be true, and you are not going to prove them ever. So the 2 things that he came up with, the 2 postulates, were the speed of light is constant regardless of the source of that, so that if you have light, the speed of light is going to be measured by c by everybody, and that in all reference frames, in all inertial frames, that is moving frames. Okay, I'm seated here. There's a train going by me, and you're seated in the train with a flashlight or an LED flashlight. You turn that on to shine it. Well, I'm going to have to measure C if I have my instruments. That is, if I'd have all my physical instruments to measure the speed of light, I would use those, and you would use the exact same instrument, but we would measure both the speed of C. But the thing is that it's coming from the same light source. My time would have to, if you're on the train, to do that, your time would have to slow down, your length would contract, and your mass would increase. This is because for you to not violate Einstein's theory or Einstein's postulate or Einstein assumption that you will measure that the speed of light will be measured in a different speed, the way it works, believe it or not, is the mathematics that they calculate will then say that you will have to have the physical world change in order for us to measure the speed of light the same. That's what it's saying. That is, if you are an engineering student, if you are a student who is a person who is a critical thinker, the first thing you're going to say is why? Why does length contract? And then what we do is we actually have people with length contraction say, well, as you go, if there's some type of ether or something out there in empty space that lights a medium in, well, we're traveling against it, so it smashes us. That's what people will say. So that's one of the ways we humans try to physically justify all these things that the 20th century physics came up with. And that's one of the reasons they've failed. It's because there's no physicality to anything they're talking about. But in special relativity, if you're taking a test, length contraction comes from the fact that if you have 2 different inertial frames and one is moving, and the speed, the source of light is moving to you with respect to your reference frame, your physics has to change. Now that gets really bizarre, because then you have all the different inertial frames for everything. Everything that's moving has an inertial frame. So an electron around the nucleus has an inertial frame. So what is the speed of light? It gets very complicated. But the length contraction, the mass increase, and the slowing down of time, which is really bizarre, all comes from the fact that you have those two postulates. Light travels at the same speed, and everything has to be the same in all inertial frames. So those two things nail that. That's why Einstein said this. People said this is the way it has to happen then. Because how could I, say I'm moving near the speed of light, and I myself turn on a flashlight, and that person's near the speed of light, that light to that person is going to look really slow, because it's going to go slower. It would be the same way that if I throw a baseball and you're on a speeding train, that baseball could look like it's going backwards to you. Or if it's going forward, it could even look like it's standing still. Well, if that's the case, and that's light, and you have to measure it, all kinds of crazy things happen. And because of that, many critical thinkers, right away when they hear that, they don't buy that. There's never any justification for it. Ask your physics teacher. Say, why does that happen? So, all right, length contraction. Okay, fossology. If you're still here, hopefully you are. Why is the speed of light constant through any reference frame? Good question. You're not going to like the answer. You want the real answer to that? I can answer that question. Einstein never tells us. He never tells us. He says that's the way it is. Now, the speculation is that Einstein, who said he didn't know about the Michelson and Morley experiments, what is that? Two guys who tried to find ether. What's ether? Ether is that the light that you're seeing me with. That's like ether is like the water and light is the waves in the water, basically. Or better yet, ether is the atmosphere, and the sound. Light is the sound waves. Okay? Well, they tried to find it. What they found is they couldn't find it. No matter where they measured, they couldn't seem to find the ether. Again, that's a general statement. Those of you who've looked into this know it's more complicated than that. But what happens is that because Einstein saw that and didn't say anything about it, but he knew about it, absolutely he had to know about it. I mean, come on. Then he says, well, if that's the case, no matter where we measure, no matter our reference frame, no matter we're moving around the sun on this side, and the next time we're going in the opposite direction, if there was an ether, well, there isn't, because we can't find it. Therefore, what's really happening is that the speed of light is going to be measured, for all of us, no matter how we're moving relative to anything in the universe, including the source of the light. He came to that conclusion. He did not have evidence for that. In fact, fossology, or F-O-sology, however you pronounce that, what I would say is, what we think, Ron Hatch, who's a wealthy man from his work from GPS, who still works in GPS, I'm not sure, maybe he does, but they gave him a salary he couldn't refuse. He's got over 30 patents in GPS. He says that GPS shows the flaws in relativity. In fact, the 0.52 or 0.53 or 0.56 picoseconds, everything is off from the satellites. You know what he thinks? He thinks it's because you have to add the speed of light to the speed of the satellite plus the speed of light on one way, c plus v, v being the speed of the satellite, and then on the way back you have to do c minus v. That absolutely violates one of Einstein's postulates. So the answer to the question, why is the speed of light constant through any reference frame? It's because Einstein said so. There is no other reason. There is no evidence for that. There's actually evidence to the contrary, yet nobody talks about it. We're told about it, and that's why a lot of people run screaming and out of the doors and said, I'm never going to be a physicist in my life, because they're giving me rules and they won't tell me what they are. They just say that's the way it is. Sounds like a religion where it is, this is what happened, you must accept that. So I hope that answers your question. I hope he's still here. He didn't run screaming out the door. Let's see. Same question here. Why light speed constant in any frame? So, Vangala. I hope that makes some sense. Oh, okay, good. Aren't there apparently countless experiments showing that the light, this light speed constant, meaning it's not? No, there are not. There are not countless experiments. No. Give me one. Give me one. GPS is probably the closest thing we can get to, because it's the only thing that we measure extremely precisely with light. And guess what? According to Ron Hatch, we do get C plus V. So FOSology. That's one of the problems with relativity, because we repeat mantras. We said, here's what you said. Aren't there apparently countless? Okay, I like the way you phrase that. Apparently. No, apparently meaning people say it. If you say that Michael Jackson had a barometric, one of those chambers he slept in to make himself, his skin white, and enough people say that, then people start believing that. When in reality he had a skin disease and he put on makeup because he had blotches. You don't know if you've seen those things. How do I know? Well, guess what? Michael Jackson's cook lived with us for 1.5 years. She was an elderly lady, Brazilian. But all these rumors, I'd ask her about, what about this rumor? What about that rumor? Someone started, if you get enough people saying, we have countless experiments. Neil deGrasse Tyson says, we prove millions of times a day relativity right. You never can prove anything right. You can have things that support a theory, but you can never prove it right. So you're right to say the apparently countless. I ask you, Fosology, to come up with one. And if you say GPS, I'm going to give you Ron Hatch. And I think I'm going to win because he's got 30 patents in it. He's made millions of dollars in locating tractors for deer tractors on a field within centimeters using GPS. So he probably knows what he's talking about when it comes to calculations. My guess. But I like how you say apparently. Keep that critical thinking attitude. This is the best model we have. We prove that the atomic structure, the way we say it works, you don't know how little we know about it. When we have computer programs, I'm a computer programmer. When the computer programmers write programs to put together atoms, they don't have the molecular models inside. They have sort of a symbolic way that they do these things. They use it and they tweak it from what they see in reality, and they try to come up with a system. They don't model what physics tells them and it just pops out of it. We think we know a lot about a lot of stuff, and we don't. Okay, well, it's good to see some new people around here. I appreciate it. Coming up, over an hour. That's very good. I lost a subscriber. I watch all my, there's like 1,106, and I lose one, and I go crying into the night. I've lost the person. They don't. Well, a lot of people come with agendas, and that's fine. Everybody comes with their ideas and their whatever. And sometimes I'll say something that people don't like. Of course, the neutrino exists. You're crazy. I'm leaving. What I would say to everybody is, I always listen. I don't care how crazy it is. The only ones I don't listen to are the flat earthers, and I'll tell you why. Not because they're crazy. It's because they're all pulling your leg. Any of you guys out there, my subscribers, who believe that these flat earthers really believe in the flat earth, I'm going to tell you a secret. I was talking to somebody who knows some of these people, and it's a big ruse. They just want to see how far they can go. They're going to say, how outrageous can we be? So there are people out there that really believe it. There's not people out there that don't believe science exists. These things are put out there for political reasons and all kinds of stuff. And people are, it's like crop circles, right? Crop circles are made by aliens. You know, I'm not here to dump on anybody who believes in aliens or not. I'm not here for that. Everybody has the right. Do I know if they exist? I can't tell you. The best thing we have to understand is that we mostly don't know anything, and the more we admit that, the better we're going to be off in trying to find and make science go forward. So, okay, all right, we got some more comments. Muon's time dilation isn't the classic example. Isn't this a classic example of yee-hoo, I've got an answer? Well, I don't have an answer. I have somebody else who has an answer. Let me go look that up for you, and I will point to that for you. Let's see, I can go over here. The answer is Dr. Carazani. He answers this. Oh, look at this. Muon decay. Woohoo! Here's an abstract. This is for you, Vangala. Good question. A brief explanation of autodynamic principles is given. The autodynamic equations are explained, and the application to muon decay is analyzed. Autodynamics can explain the results obtained at SLAC and CERN. The author concludes that the problem of muon and pion decay remains to be resolved by experimenters. That is, okay, in the last years, many theoretical experimental papers about muon and pion decay have been published. Those publications that are related to the neutrino propose various hypotheses explain experimental results. The two comments below are from among many that illustrate the neutrino problem. So he's talking about neutrino and the problem. So he's going on, okay, application to cases of muon decay. If I'm not sure. Some of this I've translated over, and so known equation 4, then E can be found. But it's assumed. Let me just read it for you. The combination of these simultaneous equations. Okay, so he's calculating the mu decay. So for masses of neutral particles with a as a matter of fact, these concurrent events can each take 1/3 of the masses. Okay, what he's saying is that for autodynamics, the vertical axis the table, whatever. Until now, the conservation of momentum in autodynamics could be here a statistical meaning. In other words, there we go. All right, come on, I'm going to read conclusion. Autodynamics theory can explain muon decay phenomena by applying conservation of energy. Okay, what does that mean? I'm not going to get into all the details because you really want this, but this is for Vangala. What it means is, let me explain. Riccardo Carazani found out that in calculating, and this has to do with inertial frames. Carazani, the reason everyone needs to know his work, all scientists, people in physics need to know his work if you've been taught or indoctrinated with relativity, is that inertial frames in the physical world don't exist. There's no such thing as frames anywhere. The only thing we have is one three-dimensional space. And if we want to measure something, we can move a origin around and do a measurement. If there is a flashlight and me, I measure that flashlight. I don't measure the train. I don't go through a second frame. So all of the calculations for relativity are conducted through 2 frames. What do I mean by 2 frames? Do we have that here in this? No, probably not. Let me go to autodynamics. And 1 frames derivation. Okay, here we go. So what Carazani says is this. You can see this right there. Maybe I can make this even bigger. There we go. It's very simple. There's no reason to worry about the mathematics for this. You have 2 things there. You have a frame and F. You see frame F, and you have frame F prime. And there's a velocity between F and F prime. I believe you can see my cursor. So there's F prime and F. There's this P, And this is a person in their own frame on a train. That train is moving at v. Now, when you do this, special relativity, Lorentz, all those equations that calculate relativity, the relative movement. In fact, velocity is relative. My velocity to you could be 50 miles an hour, but we're all moving at 1,000 miles an hour on the Earth. So, yeah, velocity is a relative thing between objects that we measure. What Carazani says is that the frames, the mathematical frames, and the idea of a physical frame is bogus. That he shows that the mathematical frame has to be collapsed. That this V and the regular V, that is doing a V between two frames and doing a V between just the person and the observer and the event, that's what we need to do. Throw away another frame. It's between an observer and one event. That's it. And when you take away the frame, you get a different set of equations. And those set of equations are autodynamic equations. Here's SR force, and then you have AD, and there's the light source. So here's the light source, and there are two people moving within one frame. That's all Carazani is saying. I came up with these diagrams to try to make it look a little easier. You do the derivations, and you get the autodynamic equations that are very different. Here, what happens as a mass increases, makes itself go faster, it goes to zero, it doesn't go to infinity. There's no 1 over here. What is beta squared? It's v squared over c squared. What happens is with relativity, you get this equation 25 with 1 over it. Right there. This is time. Doesn't matter. 1 over this. When you do 1 over this, you put a 0 here. A c over c squared over c squared, you get a 1. 1 minus 1 is 0. 1 over 0 doesn't exist. When you take away the frame, guess what happens? It disappears. And what does it say about the world? It says that the world is autodynamic. For a mass like this thing, this glass cases from these glasses, for this to move on its own without anything from the outside, it's got to be like a rocket. It's got to use some of its mass to move at the fundamental level. That's what's happening at the very fundamental of the universe to make things move. And when you do that, you don't need the neutrino. You don't use special relativity. Now, what happens is they say with the muon, why am I doing this? How did we get to this from the muon decay? Well, if you go back to it, the equation, I'm not going to go through all this. It's pretty technical. Is this the right one? Yeah, muon decay. I'm going to get this smaller. Well, I guess for you guys, you can see it better. His conclusions. I'm going to get to his conclusions. Conclusion. The autodynamic theory can explain the muon decay phenomena by applying conservation of energy. Autodynamics does not include relativity. Does that make sense to you, Vengala? The autodynamic equations are no longer relativity. They've removed that. There's no magical anything anymore. There's no magical time dilation, nothing. There is no time dilation in autodynamics. So when Carazani found the flaw, that is, the flaw in special relativity is you can't have two frames because two frames mathematically collapse down to one. They're redundant. They're redundant. They're redundant. If you give it to a mathematician, you could say this, throw away one. It'd be like saying, my equation is 1 plus 1 minus 1 plus 1. Now 1 plus 1 minus 1 equals 1. Whatever. What it means is I'm going to take it away. 1 plus 1 minus 1. Oh, that still equals 1. What Carazani is saying, no, 1 plus 1. You don't have two frames, and then take it away. What he's saying is that's what it is. That the universe isn't 1 plus 1, and then you have to give yourself extra energy because it's no longer one thing. It's a very strange analogy. It's not maybe the best analogy. But that's what he's saying. He's saying the frames, two frames, don't exist. There are no frames in the universe. There are no frames around here. They're just objects. And there are objects in movement. Everything's in movement all the time. Oh, this isn't moving. See, it stayed. No, it's full of atoms and things are whirling around at the speed of light in there. Everything's moving all the time. And that movement is within a three-dimensional space. It's not in its own frame. Because when's a frame? Do you put it on here or do you put on the atoms on here? There's all kinds of philosophical problems you have with that. But there's mathematical problems. That is, it is redundant. It's reduced. You can reduce it. It's like saying 1 plus 1 minus 1 equals 1. No, 1 equals 1. That's simpler. So if that's the case and you use autodynamic equations for muon decay, you're not going to have time dilation because there's no time dilation in autodynamic equations. It doesn't exist. So what they say is a delay and proof of time dilation, that is time somehow slows down and that the muon decay decays at a different rate. No. It's all described Newtonian. If you use the Newtonian equations, which is autodynamics, are the Newtonian equivalent of what people consider to be relativity. They mean a very different thing. Relativity is magical, introduces paradoxes. Autodynamics doesn't say any of that. It's just movement. So there is the explanation of muon should decay. Here, okay, for those who don't know, maybe I'm sorry, people don't know muon decay. Muon decay means there's this particle that comes from the atmosphere out of space, comes through the atmosphere, and as it comes down, it decays. It goes away. It decays. It's like, radioactivity into energy. We'll use energy. Energy is a concept. Long story, but I won't get into that part of it. But it decays. And that decay, according to Newton, should happen in this time. But no, it happens in a different time frame from what it's supposed to. And because of that, they say, oh, that's an example of time dilation. The frame of reference, he's going towards close to the speed of light, that particle, therefore time is slowing down, and so that's why we get a different decay than what we think. Carazani says, nope, you're using relativistic equations, which are wrong, introduce time dilation, and then you say it should be this, when in fact if you take it away, you end up with measuring what you're supposed to measure without relativity, without the neutrino. And therefore, if you don't have relativity and you have autodynamics, there's no time dilation in autodynamics. So the reduction of the frames that are redundant and a bad system that cause paradoxes gets reduced, gets fixed by Carazani, then you have the muon decay that's not using relativity anymore. Time dilation doesn't exist anymore because it's not even in that universe of concepts. And muon decay, the timings can be explained, and he does it with a basic program. And this is his printout of a basic. If you know basic, it's one of the most basic computer programs there is. And he calculates it all using autodynamics. I hope that explains that. Oh! Okay, you're saying countless. Let me go if I can type that in here. I'm going to type in your physics teacher is not going to go for any of this. What level, if they're in the university, they will say this is all wrong, this is proven wrong. They'll go to find out about, in fact, they'll find out about Carazani's experiment at Stanford Linear Accelerator. They'll say it's been proven wrong, which is not true, because the experiment was not a good experiment, that Carazani found out that he had to do another experiment, which he then, after the SLAC experiment, didn't show the results that he was expecting. He realized it would never have done that. That was a bad experiment. By the time he tried and had a new experiment, they said, no more. You've lost your chance, child. Of course, you know, we're talking about particle physics who they try a gajillion times so they can get their stuff right. So this is the link for Carazani. If I'll guarantee they're just not going to accept it. Let me get to this. I'm going to go off here and read this thing. There you go. I'm going to read the link that Fossology said that this, okay, tests of, what's it, as it says right here. Yeah, you can look at these things up. Oops. What is experimental basis of tests? Okay, yeah. I've seen this page before. Test of theory of SR. Okay. Test of general experiments, optical extinction. Many measurements of speed of light involve the passage of light through some material medium. This can invalidate some conclusions of measurements due to the extinction theorem of that. This theorem states that the speed of light will approach c relative in the medium. We have our particle model explains all that. We don't need relativity for that. So not proof for it. Supports predictions, but it's not proof because we can explain the same stuff without relativity. Early experiments. Theory of special relativity. Invent. I like that. It was invented. That's true. Well, I could maybe make a video about this, but this is really grasping at straws, in my opinion here. Discovery of images of moving stars move in small ellipses. This is explained of aberration of the Earth's motion in the sun. It's inconsistent with the simple model of light waves in an ether and is dragged in the Earth. It's consistent with by the Earth. It is consistent with. Whoa, wait a minute. That's talking about ether, so I'm a little really confused there. So, anyways, Fossology. I'm sorry, but no problem. I can go through there and take a look at those really more one by one. Where can I find this Carazani? I want to show my physics teacher. Oh boy. Anyways, very interesting and very good questions. And of course, the my poll shows at least the 22 people who voted. Most all of them voted that special and general relativity were incorrect. But just another thing for you, Fossology, is if you go to my Einstein.wrong.com. And if you want to watch the movie, I can give you a pass to it. Those people who are here, I can give you a pass. Einsteinwrong.com. Oh boy, I don't spell that right. Just one wrong, man. It just looks like so wrong when it's one wrong. In my movie, I have Dr. Kesley, and he basically says, point blank, we do not observe mass increase in particle accelerators. Now, he says he has to unteach special relativity to his students. This is an experimental physicist at SLAC. Experimental physicists, believe it or not, are not always the biggest fans of the theoretical physicists. But what they say is, no, we have the energy because it's energy. So when we get to the end of the particle accelerator, we're going to use relativistic equations, which would say that you'd have to have more, the mass would increases. Well, mass doesn't increase, but its energy increases. What the heck does that mean? We know that kinetic energy increases, but that's not relativistic. That's Newtonian. So what happens is that's why they try to weasel themselves out of not having mass increase by saying we have it. In fact, if we don't use relativity equations in the end game, it doesn't work. It works because they added the magical neutrino. Here it is again. The end game is Newtonian. But because they use relativity, it introduces more magical energy or more magical mass. They can't find it, so they invent this neutrino that has no charge, no mass, no nothing, which is a ghost. And then they say, oh, no, wait, it's got a little bit of mass. Whereas Carazani says, don't do that, just use my equations, they're Newtonian, and you don't need the neutrino. Simpler math, he wins. So, Stanford Linear Accelerator. The guy says, we do not have mass increase. He says it on camera. It's been seen by thousands and thousands of people. So, all right, we are at an hour and a half, 90 minutes. I do see people coming in and out. I welcome any questions you may have. The idea of this channel is to get you guys thinking critically, not to accept necessarily everything you see or read. I'm not here to tell you the answer. And today's theme is you're not going to find one answer because we are in model revolution right now. We do not have a one accepted model. We have good models, and none of them are being discussed in mainstream science. None of them. They're being discussed at the CNPS, the Chappelle Natural Philosophy Society, and discussed on this channel, and discussed every Saturday. Go to naturalphilosophy.org, and every Saturday you can discuss and see people who discuss this all the time, pretty bright people. One of my favorite authors and scientists there is Harry Ricker III. He's one of our writers for Science Woke, our online magazine for critical thinkers, which is coming out sometime. I should have just majored in engineering and philosophy. You know, that's really funny. This brings up another subject that I'm going to touch upon. It's going to be volatile. And that is something that I have observed, and I have had it confirmed by Dr. Alexander Untitled. And that is the people who win Nobel Prizes in particle physics, the people who go into particle physics and who are doing all these crazy things and postulating theories that are not proven, and make other people who are in particle physics leave because they think it's in such a mess, is because it doesn't attract necessarily the brightest minds. And I'm going to give you an analogy that's totally mine, and those people who are watching, I'm going to give you a clue to something that's going to, a big theme that I've come up with. Theoretical particle physicists are the same as politicians. They're in it because they can be in it. Somebody's got to be in it. They don't have really truly any much necessarily even ambition. In fact, that's one of the things that Dr. Alexander Untitled said. He met one of the people. He asked him, a Nobel Prize winner in particle physics, why did you go into it? Well, you know, I could have been this and it could have been that. I said, yeah, particle physics. There was no passion there. There was no passion to find a model for the universe. Just did it. And so you went into it, and that's, oh, politics is this way. You call up donors, they give you money, you don't listen to the people, you vote in stuff that screws the people and makes the corporations good. Okay, I'll do that. Dr. Alexander Untitled says some Nobel Prize winners are basically just like that. They're not people with super brains that understand the world. They just decided, oh, I'll be a politician. Someone's going to run for mayor. What do I have to do? Oh, got to tell everybody what they want to hear but not do it? I can do that. That is pretty wild. Steve Beck, go into solid state matter physics. Yes. But Steve Beck, you can major in physics. My father majored in physics, and now he's working on his own particle theory, so with me. Don't, be discouraged. What I would say is, okay, here we go. I'm sorry. I wish I had this website done. I don't know what I need to do, but I got to keep kick-starting it because it's got all the answers. I keep showing you guys. Here we go. All right, I'm going to show you. We need this website up there. So if anybody has lots of money, let me know. Can help me. Or wants to help me with this. Fighting Big Science. Mr. Fussology. We have people writing these. We have Unsker's War on Particle Science. Ricardo Carozani, Stanford Linear Accelerator, where he did something and he had to fight. William Lucan's questions Einstein, and he was immediately ousted by the U.S. government because he questioned Einstein. This guy was kicked out of the University of South Wales because he was criticizing the black hole and the math, which is miraculously bad. Halton Arp was banned from the largest telescope on the planet because he was making observations. He wasn't inventing anything. He just says, you know, quasars have a redshift that are not in line with redshift that would make a big bang. We've got some problems here because they're related to galaxies. They're obviously connected to these galaxies which have a different redshift. So that means they're not moving. They can't be moving at different speeds because if they're from the same, that was going to upset a lot of apple carts. So they drummed him out. So this is what happens to you when you get to, and I will show you the homepage, and I'll get to another article much like that. Hey Dave, why can't we get this stupid website off? Good question. These are the titles that we have. Really great stuff. And here's one that I like. Look at that sign. Mr. Fussology, this is what's going to happen to you or anybody if you go to the university. I can't challenge Einstein at my university. When people come to me and say, Dave, you don't have a PhD in physics. Why should I listen to you? I said, you know what? I'd love to get a PhD in physics. I'd write it. I'd get it on something like how the Big Bang's wrong. Or I'd write my PhD thesis on the particle model and showing how it's better. Do you think any university in the world is going to let me do that? So I've got this really great article, actually. It goes on quite a bit. Here's a great meme that we have memes here. This is my own quote, quoting myself. All right, that's fine. I hate people do those voices. I apologize for doing that voice. When we discourage our students from challenging Einstein, the Big Bang, plate tectonics, and particle physics, we rob humanity of scientific progress, which is not just wrong, but immoral. And I believe that with all my heart. So I hate to break it to you. So what a lot of people do is, in fact, they leave the physics altogether. But, you know, going to solid state physics, they do really great things. That's for sure. Okay, folks, we're on 97 minutes. Any more questions or any questions that... Oh, Steve Beck, I am majoring in physics. Oh, nice. What are you doing here? Okay, guys, I do have a delay here, but Steve Beck and FOSology, why would you be here when you're listening to things like particle physics should be thrown out since 1930? There's the Earth's expanding. This plate tectonics is not a good model. Relativity's wrong. The Big Bang's wrong. Why are you guys here? I'm curious. Oh, nice. I like that. Steve Beck, right on. I'm cheering you on. I'll write you a letter of recommendation. I'm actually a founder of a university. I absolutely am. And who knows, maybe 25 years from now, this university will be world renowned because it allows everybody to question everything. That's the idea behind the university. You can go to it, university. University, yeah, .naturalphilosophy.org. There it is. Coming soon. I can log into it and show you, but we use a open source software for learning educational system. Can't remember. There's LE something. There's like an abbreviation for online course builders. And I made one course on how to use the software to make courses. So it says right here, founded in 2018, Chappelle University, degrees in natural philosophy, teaching scientific minds to become critical thinkers, something we don't do. So, Steve, you can become a professor at our university when you graduate. Yeah, it seems like evidence of modern physics is too thin. That is absolutely true. If you go and you look at it, and you look at physiology, if you go and look at what they say is proof for special relativity, you're going to find it super thin. You're going to look at it and go, what? That's what you're going to find. Yes, I agree. Not just modern physics. Yeah, not just modern physics. Geology. Why aren't they teaching expanding Earth? Because the expanding Earth is a way better. I mean, once you see the expanding Earth, you can't go back. There's just no way it's wrong. There's no way. How could it be that if you take away the seafloor bed on a globe, as Neil Adams does, and if you haven't seen that, you got to look up Neil Adams' Expanding Earth, and you take away the seafloor bed, you do nothing else. You take away the youngest part, the last 10 million years, then you take away the last 20 million years, 30 million, all the way back to 200 million, and the Earth closes up on a ball with all the continents fitting together. Someone calculated, I think it was 96 septillion to 1, that would actually happen in real life. Why aren't they teaching this in the university? In ours, you do. What's the evidence there is Newton's law of gravitation besides Cavendish experiment? The two masses attract. Okay, that's a good question. The answer is Newton has an equation for describing bodies in a gravitational field, the attraction. Got that? Now you asked the question, what evidence is for Newton's law of gravitation? I would say to you that that's not really such a valid question. The question really should be, what is the mechanical mechanism for gravity? And if you were to ask Einstein your question, Newton that question, I bet he would give you the same answer I just gave you. And that he said, paraphrasing, don't ever accuse me of knowing what gravity is. And so the answer is what evidence of Newton? There is no evidence for things. You have things that support a theory. What you can support is that when you make measurements of falling bodies, or you make measurements of planets and orbits and those kinds of things using Newton or Kepler, which is, whatever, those numbers and those equations work out pretty well. You can do quite a lot with Newton. That supports that his equation is good, very good for describing, very useful for describing bodies in gravitational fields, whether it be orbiting or falling objects. The Cavendish experiment is just to try to come up with some of the constants to be involved so that we can make the equations. Now, if you want to know about G, look at, I'm going to type it in, go to YouTube. So, physiology about the Cavendish experiment. You go to this channel. I happen to know this guy pretty well. YouTube.particle.guru. Look that up. Look up Bob D. Hilster. Okay, Hilster. Look it up on the internet, on YouTube. And gravity constant. Turns out that the gravity constant that we have for the Earth is for the Earth. That G is not a constant. G is a fudge factor that we use for the equation to work. And that the real question again is, what is the physical cause of gravity? Is it an electrical force, as some people think? Is it a particle force like we think? It's just all the G1 particles, all the electrons flying around throughout the universe, and those electrons are just flying in all directions, and they hit on stuff, and because they hit on stuff, they're a constant little push, and they cause two bodies together. Those electrons are coming together, and they block some out so that there's an attraction there. Is it like James says that gravity is because the Earth is expanding and all bodies are expanding, and because of that it's pushing us up? What is it? That's the question. Well, people are saying, Dave, you've been going on too long. So, all right, I'll take any more questions if you do have them. I know people keep popping in and out. I appreciate you guys subscribing. This channel's, this live session's here for people to ask questions and interact, because a lot of times people will ask a question of me in a comment and I'll talk, but having an interaction or a conversation about something doesn't always, gives a lot more feedback, I think, and also gives me a lot more time to give a complete story about some things. And sometimes a lot of things that come out in these live sessions, if you're watching this recording, they seem to give us different stuff than from when I prepare. So that's pretty cool. Alrighty, folks, I think I'm going to end it here since I don't see any more questions or interactions. I appreciate you all hanging out here. Let people know about the channel. If you have any questions, let me know. If you want to help out with our new website, I'd be love to have that as well. If not, just let people know about this. If not, also just keep tuned, and just honest to goodness, try to keep your mind open. Try to remember that modern physics is giving us nothing that's physical. They don't tell us what light is. They don't tell us what gravity is. They say there's mass increase because of movement. They don't tell us what that is. They say there's a big bang, but can't explain, well, why did that happen? Why would anything come together? Why is it spreading apart? And why do we have violations to the redshift that supposedly does? There's just too many problems. And relativity, we have evidence against it. General relativity, we don't see starlight bend outside of the coronas of sun. So we have come to the conclusion that light bends, but within a mass. Like, there's a corona of the sun's like water. Put a stick in water, you can see it bend. So, folks, stay critical, stay thinking. I'm David D. Hilster, your science therapist, and hopefully getting you to the promised land and become science woke. Greatly appreciate your patronage. Thank you so much. Good evening, good morning, good night, wherever you are. Ciao for now.